Okay, let's call this slide painless kidney because I want to oversimplify things for you intentionally, and I'm trying not to use a lot of esoteric words which really don't matter and which will confuse you for the rest of your life anyway. Notice every kidney has an area generally towards the outside of the kidney in which you could see these little glomeruli, and this is called the cortex. Notice deeper within the kidney, you have predominantly tubular structures, and this is called the medulla. Notice how the medulla is often shaped on many sections like a little triangle, and that's why this is called a renal pyramid. Please notice also that at the tip or the apex of this pyramid, which is right here, this is what is known to as a papilla or renal papilla. Please notice that the renal papilla dips into a urinary space lined with transitional epithelium called a minor calyx. Please note that several or one or more minor calyxes will fuse to form a major calyx, which we don't see here, and 3 or 4 major calyces will then fuse to form the renal pelvis, and then the renal pelvis will rapidly taper off into the ureter. But let's not get ahead of ourselves. Here is your medulla, which is pyramid shaped. Here is your cortex. Sometimes the cortex can dip between the pyramids, and that's known as the renal columns. Let's take a look at the cortex first, and then let's take a look at the medulla. The cortex, or cortical tissue, is always quickly identified by the presence of these numerous glomeruli. If you wanted to do things right, you would realize that the very first thing that you see on the kidney is a fibrous capsule. I don't think the fibrous capsule was here too well. It may have been stripped off a little bit. This may be part of it here, but I don't see any connective tissue on here. But I do see a bunch of glomeruli. The glomeruli are surrounded by tubular structures. 90% of these tubules have lumens which are so filled with cytoplasm. They are called proximal convoluted tubules. These are all proximal convoluted tubules here and here and here. If the tubules in the cortex are have enough guts to form an actual lumen, then this is a distal convoluted tubule. Here's a distal convoluted tubule here. The rest of these are proximal, and here we have the glomeruli. The glomeruli always have a free end, which is completely surrounded by space, and that's called the urinary pole. And then they have an area of attachment to blood vessels, which is called a vascular pole. Often, if you're lucky, in the vascular pole, you may be lucky enough to see structures that have a lumen, and that would be the portion of the distal convoluted tubule which comes in proximity to the vascular pole to form the so-called juxtaglomerular apparatus. And I'm not going to take you any further than that. I will also tell you that both the afferent and efferent blood vessels come into the kidney at the vascular pole, and it is usually impossible in real life to differentiate them from each other. But what you can differentiate are the fact that all these are proximal tubules here and here. Here's a distal tubule because it has a lumen. Here's a distal tubule because it has a lumen. Here's the glomerulus. Here's the vascular pole attaching it. And here is the urinary pole, which is the free side. Where the cells of the proximal convoluted tubule come in contact with the vascular pole or tuft of the capillary, that's where you will see them lining up flat to form cells which will be crucial in renin production. Otherwise, if you look in any glomerulus, and we will, let's get a nicer, looser one. I can tell you that there are only three kinds of cells within the lumens, within the glomeruli. And one of them are the cells called podocytes, which is also called the visceral Bowman's epithelium. The parietal Bowman's epithelium lines the outside of the space, like here, whereas the podocytes form the are on the inside of the capillary. The other type of cell that you may see in a capillary, especially if it looks like it has sort of a spindly shape and perhaps there's some blood vessels in it, those would be the capillary cells. The third type of cell you see in a side of a glomerulus is a mesangial cells. They are seen all throughout the all throughout the glomerulus, but they're more common towards the vascular pole. The problem is, really, in all honesty, at 20 power on an H&E stain, you often really can't differentiate between those three types of cells easily. But if you did special stains or had EM, you could see beautiful differences. Otherwise, you could say this is a distal tubule. These are proximals. Here is the urinary pole of the glomerulus. Here is Bowman's parietal epithelium. The cells in here which surround the capillaries are Bowman's visceral epithelium, also called podocytes. And some of these cells, which are more common towards the vascular pole, perhaps here and here, but you never really know for sure, are the mesangial cells, which are the so-called scavengers or immune cells, or perhaps macrophage-like cells of the glomerulus. And I really don't want to get into kidney any further than that, because we have identified all the major structures, and you really can't identify any more in H&E. Here's all proximal, here's all distal, here's a glomerulus. You know the three types of cells in the glomerulus. You know that the outside is lined by the visceral Bowman cell. You know that the parietal Bowman cell is called the podocyte. You know that the other two types of cells in the glomerulus have to be mesangial cells and capillary endothelial cells. We've already seen the beautiful, beautiful deeper part of the kidney called the medulla. And we could see how the medulla is generally shaped like a triangle. And we could see that the very tip of that triangle is called the papilla, or renal papilla. We can also see that the urinary space is now lined by a very specialized type of epithelium, which is transitional epithelium. And this transitional epithelium now will extend from the minor calyx all the way to the urethra. And notice that it, like squamous, is stratified, but has somewhat of a cellular conformational change depending on whether this space is distended or compressed. There's usually connective tissue and smooth muscle surrounding this, no matter what part of the lower urinary tract you're in. And that's really all I want to say about kidney, and I thank you very much.